Welcome to the deep dive. Ever felt like building a robust backend with Node.js is less like engineering and more like, well, herding cats? You're juggling frameworks, libraries, architectural decisions, maybe constantly wondering if there's a more structured, scalable way. Well, today we're cutting through that complexity. Our mission on this deep dive is really to demystify NestJS. We've got a fantastic source, the NestJS Handbook, and we're going to, extract the most important bits, give you a clear understanding of what NestJS is, why it's kind of a game changer, and how you can start leveraging its power. Think of it as your shortcut, really, to understanding modern backend development. By the end of this, you should have a solid grasp of NestJS's core philosophy, its building blocks, how it handles databases, authentication, basically giving you those aha moments without the overwhelm. So let's jump in. Okay, so many of us love Node.js for server-side stuff because it's so flexible, right? But that flexibility sometimes, maybe in larger projects, it can lead to a bit of a Wild West situation. NestJS seems to bring structure right from the get-go. What is it at its core?
Right. So what NestJS really does is provide this progressive Node.js framework. It's specifically for building efficient, reliable, and importantly, scalable server-side apps. It's written primarily in TypeScript. You can use JavaScript, but TypeScript is sort of first class. And it cleverly blends paradigms like OOP for structure, FP for predictability, even FRP for async streams. And it builds all this on top of really battle-tested foundations like Express or alternatively Fastify.
Okay, that sounds like a potent mix. I've heard that if you come from, say, Angular on the front end, it feels quite familiar. Is that part of its story?
Absolutely. That's a key part of its origin and philosophy. It was created by Kamil Milivik back in 2017. And it wasn't just, let's make another framework. It was a very deliberate effort to bring Angular's strong architectural patterns to the back end. That clear structure modules, controllers, services, plus a really robust dependency injection system. It was about solving some fundamental problems in Node.js development.
Like what specifically? What problems was it targeting?
Well, the core goals were really about consistency, having one opinionated way to structure things so teams are on the same page. Scalability, those clear module boundaries help as projects grow. Testability was huge too. Built-in jest support, separation of concerns makes isolated testing much easier. And extensibility, a pluggable module system for ORMs, WebSockets, GraphQL, microservices. You name it.
So it provides guardrails, but doesn't completely lock you in. How does it actually work under the hood? What are the mechanics?
Yeah, it boils down to maybe three core ideas. First, modularity. Everything lives in these focused units called modules, like you'd have an app module or a user's module for user stuff.
Okay.
Second, dependency injection, or DI. This is massive. It lets components, especially services holding your business logic, get easily injected into controllers. Promotes loose coupling, great for testing and flexibility.
Right, so components aren't tightly bound together.
Exactly. And third, decorators and metadata. NestJS uses these special keywords like @module, @controller, @injectable. They add info to your classes. Then NestJS reads this info at runtime to wire everything up automatically. It's very declarative. You just state what things are.
That focus on structure sounds powerful. The handbook gives a little example, doesn't it? With a user's module. Could you walk us through that just to make it concrete?
Sure. So imagine you're building user features. You'd likely have a user service class. You mark it with @injectable. This class holds the logic, maybe fetching users from a database.
So the business logic lives there.
Right. Then you have a user's controller marked with @controller users. That tells NestJS this handles requests to the user's path. Now the key part, in its constructor, the controller injects the user service. It doesn't create it. It just asks NestJS for it. That's the DI in action.
Ah, okay. Loose coupling.
Precisely. The controller might have a method like @get users, that just calls a method on the injected service, like this.userService.findAll. And finally, you group the user's controller and user service together in a user's module file using the @module decorator. You declare the controllers and provider like services for that module there. It's a really neat way to bundle related functionality.
Yeah, that sounds very organized. So beyond the core philosophy, what are the really tangible benefits? Why choose NestJS over, say, Express or Koa?
Well, the handbook points out several practical advantages. First, those strong architectural patterns we just discussed. Modularity forces you to break things down, auth module, products module, etc. This naturally leads to a clear separation of concerns. Controllers handle HTTP, services do the logic, modules wire it up, and this structure really helps with scalability. Adding new features often means just adding a new module without messing with existing code too much.
And that built-in dependency injection you mentioned must play a big part there, too.
Huge part. Having built-in DI is a major win. It makes testing so much easier because you can effortlessly mock dependencies. The handbook shows a nice example of testing a controller in isolation. Another massive plus is its TypeScript-first approach. It's not an afterthought, it's deeply integrated. Full type safety catches errors at compile time way before production. You use interfaces and decorators to define and validate data structures.
That compile time safety is definitely appealing. What else stands out?
The rich ecosystem and extensibility. NestJS has official packages for WebSockets, GraphQL, microservices using RabbitMQ or Kafka. Lots of heavy lifting done for you. Plus, the community provides tons of modules, like for generating OpenAPI docs automatically. And finally, the tooling is excellent. The CLI, NestJS, etc., generates boilerplate, you get hot reloading during development, npm run start.dev, and just testing is set up from the start. It speeds things up and keeps things consistent.
Okay, so connecting this to the real world, where does NestJS really shine? What kind of projects is it best suited for?
It excels in a few key areas, definitely enterprise APIs, especially where you need strict boundaries, complex authorization, and larger teams working together. Also, microservices architectures. Each service can be a clean NestJS app, real-time applications like chat or live dashboards. Its WebSocket support is great. GraphQL backends, particularly if you like the code-first approach, and event-driven systems, integrating with message queues.
Right. Now, this is where it gets really interesting for many people. How does it actually stack up against the old guard like Express or maybe the more modern Koa?
Yeah.
The handbook has a comparison, right?
Yeah, and it's quite telling if you look at architecture. Express is minimal, Koa is middleware-focused, NestJS is opinionated modules, controllers, services. It gives you structure immediately.
Okay.
Dependency injection, manual and Express Koa built in with NestJS.
Yep.
Huge difference in practice. TypeScript support. First class in NestJS. With Express Koa, you're relying on community type definitions, which can sometimes lag or have gaps, and CLI tooling. NestJS has @NestJS, scaffolding and generation. Express and Koa don't really have an equivalent official tool.
So it sounds like Express and Koa offer more raw freedom, maybe, but NestJS gives you a lot more out of the box. When would you pick one over the other?
That's a good way to put it. Choose Express if you want minimal layers, total control, and you're happy building your own structure, DI, validation, etc. Koa offers more modern middleware, but still leaves architecture largely up to you. But yeah, if you value consistency, type safety, built-in best practices, especially for larger APIs, microservices, or just teams wanting a standard approach, NestJS provides that robust foundation. It lets you focus more on business logic faster.
Okay, let's get practical. For someone listening who's thinking, all right, I want to try this, how do they actually start? The handbook makes it seem pretty straightforward.
It really is quite easy to get going. First step is installing the Nest CLI globally. You'd use npm install -g at nestjs. Just need a reasonably recent node and npm version.
Got it. Global CLI.
Yep. Then you just run your project name. The CLI asks if you prefer npm or yarn, things like that. Once it's done, you cd into your project directory, my Nest app or whatever you called it, and run npm run start.dev. That fires up the development server, usually on localhost 3000 yarl, and crucially, it has hot reloading built in. So you save a file, the server restarts, changes appear, super efficient for development.
Nice. Takes away a lot of that initial setup pain. And what does the project look like once it's created? What's the default structure?
It gives you a really logical starting point. Inside this SRC folder, you'll find key files, app.controller.ts for basic requests, app.service.ts for sample logic, and app.module.ts, which is the root module tying things together. There's also main.ts, that's the entry point script that actually bootstraps the NestJS application using something called Nest Factory.
Okay, the core pieces.
Exactly. It's a minimal but fully functional app. And the CLI makes adding more features easy. You can run NestJS-module tasks to create a new module for tasks, or NestJS controller users for a user controller. It generates the basic files with the right structure and decorators already in place.
Cool. So NestJS isn't just about the initial setup. It seems very involved in the whole request lifecycle.
Right.
Let's dig into some features that handle incoming request processing, validation, security. Maybe start with pipes.
Right. Pipes are fantastic. Think of them as data sanitizers and validators that sit right at the entrance to your route handlers. They're injectable classes that run before your controller method gets the request data. They do two main things. Transformation, like converting a string 123 from a URL parameter into an actual number 123.
Okay, useful.
And validation. This is huge. They check if the incoming data conforms to rules you define. If it doesn't, they throw an exception, like a bad request exception, stopping the request right there. Bad data doesn't even reach your controller logic.
So your controller code can trust the data it receives.
Pretty much. A really common pattern is using the built-in validation pipe globally. You combine it with a library like Class Validator. You define your validation rules directly on your data transfer objects, DTOs, using decorators, maybe at IsEmail on an email field, at min-length on a password. Set up the pipe once in main.ts, and NestJS automatically validates incoming request bodies against these DTOs.
That saves so much boilerplate validation code in the controller. Okay, what about controlling who can access what?
That's where guards come in. If pipes check the data, guards check the caller. They run after pipes, but before the controller method. A guard basically answers the question, should this request proceed? It returns true or false, or it can throw an exception like forbidden exception.
So for authentication and authorization.
Exactly. Perfect for checking if a user is logged in, authentication. Or for role-based access control, RBAC, does this user have the admin role required for this endpoint? You can apply guards globally per controller or even to individual routes using the useGuards decorator.
Very granular control. Now, inevitably, things go wrong sometimes. How does Nest handle errors without crashing or sending cryptic messages?
Good question. That's the job of exception filters. NestJS has a default one that catches its own standard HTTP exception types, like not found exception, which results in a 404. If an unexpected error happens, it sends a generic 500 internal server error.
Okay, a baseline.
But the real power is creating custom exception filters. The best practice is for your services to throw specific exceptions when something goes wrong, like throw new not found exception product with ID 5 not found. Then you create a custom filter using a catch that specifically intercepts not found exception or maybe all exceptions. Inside the filter, you can log the error details, format a consistent user-friendly JSON error response for the client, maybe add tracking IDs. It centralizes all your error handling logic.
Keeps the controllers cleaner, focusing on the happy path. And one more piece in this request flow puzzle, interceptors. What do they do?
Interceptors are super versatile. They let you hook into the request response cycle around the execution of your route handler. They essentially wrap the controller method call.
Wrap it. How?
They implement an intercept method. Inside this method, you typically call next.handle, which executes the route handler. But you can run code before that call, and you can use RxJS operators like map or tap on the result after it comes back from the handler.
Okay, so what would you use that for?
Lots of things. Transforming outgoing responses, maybe wrapping all successful responses in a standard success through data envelope. Or automatically removing sensitive fields like a user's password hash before sending the user object back to the client. They're also excellent for cross-cutting concerns, like logging or metrics. You could have a login interceptor that times how long each request takes to process and logs it, like get tproducts 12342 meters. Very powerful for observability.
Right, that makes sense. So we've seen the structure, the request handling, but real apps need databases and configuration. How does NestJS handle those critical pieces?
Yeah, absolutely essential. For database integration, NestJS integrates really smoothly with popular choices, making them work well with its dependency injection system. For relational databases, PostgreSQL, MySQL, etc., TypeORM is a very common choice. It's a full-featured ORM. NestJS has @NestJS TypeORM, which provides modules like TypeORMModule.4 for setting up the main connection and TypeORMModule.4 feature to make specific entity repositories available for injection into your services.
Okay, so it plugs right into DI. What about NoSQL?
For NoSQL, particularly MongoDB, Mongoose is the go-to. Again, there's @NestJS Mongoose with a similar for-root and for-feature methods for connection setup and registering Mongoose models, which you can then inject.
And are there other modern options people use?
Definitely. Prisma is gaining a lot of traction. It's a bit different. More of a type-safe query builder and ORM generated from a central schema file, schema.prisma. You define your models there, run migrations, and Prisma generates a client you can use. You typically create a Prisma service in NestJS that initializes and provides this client and then inject that service. It offers fantastic type safety and developer experience. The key takeaway is that NestJS makes integrating these data layers feel natural within its architecture.
And configuration. Managing API keys, database URLs across dev, staging, prod.
Yeah.
That can be messy.
Totally. That's where the @NestJS config module comes in, and it's really well thought out. It centralizes how you load, validate, and access configuration variables.
What are the main benefits?
Okay, so first it loads config, usually from .env files, and you can specify different files for different environments. .env, .development, .env, .production. This keeps sensitive info out of your code. Second, and this is crucial, it integrates with validation libraries like Joy. You define a schema for your expected environment. Variables like database URL must be a string, port must be a number. If a variable is missing or the wrong type when the app starts, it fails fast with a clear error. No runtime surprises later.
That validation sounds incredibly useful. Prevents silly mistakes.
It really does. It also lets you namespace configurations, like having a database config object with host and port inside. And then you inject the config service anywhere you need settings and retrieve them type safely, like config service.getNumber, database.port. It adheres nicely to the 12-factor app principles, keeping configs strictly separate from code.
Excellent. Okay, now for maybe the most critical part for many apps. Authentication, securing endpoints, handling logins. How does NestJS approach this?
NestJS provides a solid foundation, usually leveraging the Passport library, which is like the Swiss Army knife of Node.js authentication. A very common strategy, especially for APIs, is using JWT's JSON Web Tokens.
Right, JWTs. Remind us quickly what they are.
Sure. They're basically these compact, secure strings that contain information or claims like the user's ID, maybe their roles. They're digitally signed by the server so you can verify they haven't been tampered with. The client gets a token after logging in and sends it back with every subsequent request, usually in the authorization. Bearer token header. They're stateless, meaning the server doesn't need to keep track of sessions.
So the server just checks the token each time. How does that work in Nest?
Exactly. You typically use the @NestJS JWT module for creating, signing, and verifying tokens. Then you use @NestJS Passport along with a specific passport strategy, like Passport JWT. You create a JWT strategy that knows how to extract the token from the request and validate it. Check the signature, expiration. Then you create a JWT Auth based on this strategy. The flow is, user logs in, your auth service validates credentials, creates and returns a JWT. For protected routes, you apply the JWT auth using @useguards. JW auth guard. The guard automatically runs the strategy to validate the token on incoming requests. Access denied if it's invalid or missing.
That sounds pretty streamlined. What about other methods like sign in with Google or GitHub? Yeah, OAuth 2 social login. NestJS handles this well too, again, usually via Passport. You use specific passport strategies like Passport Google Auth 20 or Passport GitHub 2. The flow is a bit more complex, involving redirects. Your backend initiates the OAuth flow, redirecting the user to Google, for instance. Google authenticates the user, then redirects back to your app with a temporary code. Your backend exchanges that code with Google for access tokens and then uses those tokens to fetch the user's profile info, email, name, etc. Okay, so you get the user info from the provider. Then what?
Then typically, you'd look up if you already have a local user account associated with that Google ID. If so, you log them in. If not, you might create a new user account in your database. Crucially, once your backend has authenticated the user via OAuth and has their profile, you usually issue your own JWT to the client. The client then uses your JWT for all subsequent API calls, just like in the regular JWT flow.
So OAuth is just for the initial sign-in, then you manage the session with your own JWT.
Exactly. And of course, things like oath client IDs and secrets absolutely must be stored securely using the config service, not hard-coded.
Wow, okay, we have covered a ton today. Seriously, from the core ideas, modularity, DI, TypeScript, to all those request lifecycle features like pipes, guards, interceptors, and then into the really practical stuff, database integration with TypeRM, Mongoose, Prisma, handling configuration properly, and finally tackling authentication with JWTs and OAuth. NestJS really does seem to offer this comprehensive, structured way to build Node.js backends.
It does. You really see how that initial philosophy translates into tangible benefits. The consistency, the testability, that clear separation of concerns. It's all baked in. Whether you're using SQL, NoSQL, or Prisma, it integrates nicely. Securing it feels robust.
Yeah, I think NestJS really excels at providing that solid, almost enterprise-grade foundation. It lets developers kind of bypass a lot of the early, often tedious setup decisions and boilerplate. You get to focus faster on the unique business logic, the stuff that actually makes your application valuable. Which leads to an interesting thought, doesn't it? What kind of cool, innovative solutions could you, the listener, build if so much of that foundational plumbing is already handled so well for you? You can potentially move faster, build more complex things with more confidence.
That's a fantastic question to end on. It really makes you think about the possibilities. If you're eager to continue this deep dive and start building, we definitely recommend checking out the official NestJS documentation. It's excellent at docs.nestjs.your online, and their GitHub repo is great too. Thanks for joining us on the deep dive. The adventure definitely continues.